All right, guys, and welcome back for part 11 in our video series. So you want to build a gaming PC, why you should get into PC gaming. And today I'm excited because we're going to get into a topic that I really love, which is storage. It's not that I'm in love with storage. It's just it's one of those topics that does not get a lot of coverage beyond what brand you should buy and buy the fastest. And if you've been watching this series, you'll kind of notice the trend of things I'm talking about is underserved areas of knowledge within PC gaming and just technology in general, because there's a lot out there of like, you should buy this, buy that, and this is the fastest, but real world applications and practical use of these things is not really discussed much. A lot of the videos I see are by tech channels, and I've said this numerous times. I love them. I love what they do. They give great deep dive information, but it doesn't really show you how that relates to you when it comes to, drive speed and stuff, because a lot of the performance that people buy into, they're never going to touch, or if they are, it's going to be years upon years down the road. And so that's important, because we got to find that in between when we're building a PC, especially a gaming PC, of what do I need right now and what is going to be usable in the next few years, or how long can I make that last so I'm not having to constantly dump money into this machine. So today we're going to talk about storage. We're going to go over a lot here. I didn't want to make this a keyword heavy video, so to speak. Like, I don't want to go over every single term there is to know within storage, because I feel it's going to get very verbose, and this is already going to be a long enough video, I can tell you that. But I want you to become familiar with a few concepts with hard drives, NVMe's, SSDs, basically storage that you're going to use in a computer, to be aware of, because these are very important. These are things that are not talked about enough and not directed towards new users. And I'm hoping that this video and the series I'm doing is getting to people who are wanting to get into PC gaming. Maybe you're just building a PC and you've caught this and you're like, hey, I think I want to build something. I want you to come away with this with some knowledge and basic information about parts, because that's going to be important to save you money, to know what you're looking at, and in some cases, maybe some basic troubleshooting. More so this video than others, because storage is the one thing that users notice failing without knowing it first. And this comes from me spending years in IT, and while most users can't really pinpoint an issue, one of the bigger issues is failing storage, and they're able to pinpoint that pretty accurately. So that's what we're going to talk about today. The main focus of this video is going to be, for the gaming portion of things, why you should have 3 different hard drives within your system. I know that sounds insane, and we're going to go over why that's important. It's a setup I started doing years ago, and it provided better results in a lot of areas in just PC use in general, but also for the longevity of your machine. It's very important to do this. Now, I know some people are going to be like, oh, I've been fine, I've just got this standard drive, but we're going to go over the reasoning for why it is you need to have 3 different drives at a minimum, and what that would look like and what you should be doing. So let's go ahead and jump into that, guys. All right, so what is the setup you should be using in a gaming rig? And some people are probably going to disagree with this, but I found a lot of success and use with doing an NVMe for your primary drive, a cheaper drive if price is right for that, an NVMe, mid-range faster for your gaming NVMe, and then a mechanical hard drive at higher capacity for a lot of your other game library mods, stuff like that. And we'll dive into why that setup is optimal, because there are a few good reasons for that and why you should really look at that. I feel a lot of people are overlooking mechanical hard drives today, and they're still very, very useful for a lot of applications in gaming. And they have their benefits as well. So before we go over that, I wanted to go over some details about storage. So NVMe's, SSDs, and hard drives, to give you an example of what we're looking at and the limitations of that hardware, and why it's important to understand, why some of this may be a waste. Because some people are going to be told they need to buy fastest for a drive, and it's really not going to matter. So let's go ahead and pull up some information here on read-write speeds for drives. So traditional hard drives, be it a laptop drive, be it a desktop hard drive, the old stuff that a lot of you may not even think about using at this point, those have a limit of between 80 megabytes per second, 120 megabytes per second. So you can kind of get an idea of why those are not going to be optimal for modern gaming. So games like Cyberpunk are not going to run on a hard drive. And for that matter, they probably won't run well on an SSD, even though the SSD speeds are a little bit faster there. I'll talk more about that later on in this video about kind of some of the issues you'll see. As a side note, I do think a lot of people, when games like Cyberpunk were coming out and Dying Light 2, I'll talk about that because I have my own personal experience with that. I think they were trying to run these games on older storage mediums that were not fast enough to handle the games, and we're seeing issues, and that's where a lot of these games got a bad rap. Now, Cyberpunk had some optimization issues, no doubt, but I do think there were issues, and there have been issues with a lot of AAA titles where they're not running well because people do not have adequate storage or the right type of storage. So, but anyway, you can kind of see the change in speeds there between just standard hard drives. And in this case, for everything we're talking about, we're generally talking about 5,400 RPM speed on drives because 7,200 is a waste. It's more expensive. There's issues that come with that. I'll touch on that later on in this video. Yeah, we're not going to be talking too much about 7,200. 5,400 RPM is where you want to be. And then the SSDs, these look like laptop drives, and they would have been very small, and you would have seen them. They started installing those in desktops. I was employed on a number of projects where we swapped out old hard drives in Windows 10 for SSDs to make the systems run faster. It was a nice, cheap fix. This was, a few years ago. This was definitely pre-COVID. And so companies were buying boxes of SSDs and swapping those into systems to improve performance because the changeover from an HDD at 5,400 RPMs going to an SSD was dramatic. Windows just worked better. And you can see cases where it does help marginally on things. Desktops are one where it did really well. There are videos, if you want to go hunt them out, if I can find it, I'll link it in the description below, but where somebody loaded Skyrim on an Xbox, I think it was an Xbox 360 with the standard hard drive and then an SSD, and then they did on an XboxOne with a standard hard drive and then an SSD, and there was an improvement. There was an uplift in load times. And then lastly, the NVMe, these are the stick-based drives that you're seeing now in modern systems, which you should be running some iteration of that for your primary OS. They get much faster. You can see the speeds there. They're moving much faster. Even the budget drives are a leap and a bound above where SSDs are or where HDDs are. Now, in a modern system, you can still run SSDs, but I think right now in this day and age, the price is not going to be that different. So if it's a choice between getting an SSD for your OS or getting an NVMe, I would say if the price is about the same, get the NVMe. If you're really trying to save money and you can find a good discount on a cheap NVMe drive that's going to be, okayish in speed, go with that. You will notice somewhat of a performance hit, but that's going to be on the Windows side. And again, with the layout, the drive layout I'm talking about, even if you have an SSD as your primary and then you have an NVMe for your gaming drive, you're going to still see a benefit from this layout if you're using 3 drives. It's just, I would recommend, if you can, just for longevity of the machine, get an NVMe if you can. If you have no other option and all you've got is an SSD, use that. But you do not want to use an SSD for modern games. It's Cyberpunk, Baldur's Gate 3, stuff like that is not going to run exceptionally well on an SSD. Will it run? Sure, but expect some issues. So I'll put that there. Those games were designed to be running on an NVMe Gen 4. And again, you can see the speed difference. That's why these are chunk loading a lot. I had a note here someplace. I don't know where it went, but I think, oh, there it is. So to give you an example of both why you need these faster drives and why there's diminishing returns as well. I pulled up just a quick, how much data does Cyberpunk load when you start the game? And it's at up to 15 gigs. So obviously you want a drive that can load that really fast. And let's say we were hitting the theoretical maximum here, which I should have noted that these are theoretical maximum in speeds. But let's say you have that higher end NVMe at 7.4 gigs of read speed, because read speed is what's going to be used when loading your game up. When you start that game and you're loading it up, it's that chunk loading right at the beginning. 7.4 gigs. That means if you do some basic math, a little over 3 seconds is how long it should take to load 15 gigs of data. Now, there's going to be other bottlenecks in there, processing, RAM. Even though those are going to be fast, you may see some variance. So it could be 3 seconds, it could be 4 seconds, maybe 5. That's still pretty snappy for an environment the size of Cyberpunk to be loading. Same with games like Dying Light, open world. For them to load that fast, that quickly is great. Now, Obviously, if you go to a, an entry level NVMe, you're going to see a difference in load speed. But imagine trying to run, and this is where people were having problems, trying to run Cyberpunk, loading that 15 gigs on an SSD. It's just not going to go well. And yes, I know they implemented a compatibility mode, but we've seen what that does. It reduces the number of assets loaded. So the world looks a little bit emptier. And in videos where I've seen them running that, it's the same car all the time. Does anybody remember old Grand Theft Auto Vice City, where the cars would, as soon as you stole a car, multiples of that same type would start showing up right after that? It's kind of the same thing. It's the way it's loading. So, just for reference, kind of what it looks like with those there. So let's remove this. And then I wanted to put up another image here, which is kind of showing you file sizes. If you're curious about the different sizes, we have kilobyte, that's, a step above bytes. We really don't have files that are using that much anymore. Images are generally in the kilobytes or megabytes these days. Back when I first got into computing, images could be a few bytes. They were real small. We're talking pre-GIF, pre-GIF. As widely used. We're talking real tiny thumbnail size images that people used to share, because resolutions 1024 768 or 600 by 800 screen resolution, images did not have to be that high resolution for it. So a desktop image was probably the largest thing you had for an image at the time for a general use, compute use. Games, even if you go back to older games, if you have disk copies, a lot of the graphics on disk were very small. They did not take up a lot of space, but hard drives are also smaller. So a lot of that data ate up hard drive space very fast. I remember, I forget what title it was, but I remember installing a game that was a gigabyte and thinking that was a ton of space at the time, when games were like 600-700 megs. And then I added a portion under this. I did not make this chart. It was an open source chart pulled from, I forget where, but I wanted to put relatable file sizes, because this is a part where I think technology is taught in a bad way, or is given to people in a bad way. They're given these terms, right? I don't care about the 1024 logical, because realistically, if you've been in a file system, you're not getting, when you install 120 gig drive, you're not getting 128 gigs. You're getting under that, like 108 or something, So we're going to stick with just thousands here to give you an idea, because I think it's more realistic for the common user. This storage is translatable to pretty much anything you store digital data on, if you're wondering. The exception that would be like cloud services, because they keep you kind of even in your numbers. But cell phones are the same way. They sell you a 256 gig phone, and then you get it and you're like, hey, why is there only 200 gigs available? The system reserves part of that data, if you're wondering. And there's other stuff the OS needs. That's why you lose part of that data. So that's what that's there for. Not going to get into a deep dive on that. But to relate it, a terabyte is 1,000 gigabytes. Why is that important? This will also be important later on when we talk about read-write limitations, or write limitations, I should say. But 1,000 gigabytes. Why is this important? That number gets chipped away very quickly depending on what you're storing. Cyberpunk, for example, is I think 70-something gigs, if not more. I don't have the number right in front of me, so I could be wrong on that. But Ark, for example, in that game, Ark Survival Evolved, when it came out, it was over 100 gigs. That's a tenth of that. So you can see where a terabyte goes very, very fast. And that's why I urge you to have a high capacity standard hard drive to store a ton of data for older games, indie games. It adds up very quick. Additionally, if you want the other breakdown, that's 1,000,000 megabytes, which I know that number sounds insane, but you will go through that data very, very fast. And then 1 gigabyte is 1,000 megabytes. So a ripped DVD in acceptable, for most people acceptable, storage is about 2 gigs, maybe more, a little more. That's going to go very fast. That'll add up. You can tear through data very fast without realizing it. Games add up very quick. So just a reference there for file sizes, more relatable to the average user, because I think if we look at storage in terms of, I have $1, how many pennies is that? It's a little bit easier to digest for the common user than, I have a terabyte, that's a lot of space. It is and it's not. It depends again on your application. If you do video editing, you'll understand really quickly, if you're watching this, that a terabyte is not a lot of space. Video and audio combined together take up a ton of space, especially in HD. And I'll touch on some of those numbers later on, because again, this will become important again. So keep this in mind. Because it's going to relate to lifespan of certain hardware. So that's kind of a crash course into storage. Does it cover everything? No, but those are the main ideals for that section I want you to understand and be comfortable with. If you have more questions on that section, let me know, and we can go over that a little more in depth elsewhere, or in comments I can answer. But that's the basic information you should know: is speeds. You know, obviously not to overbuy on storage in terms of speed, because there's just some stuff you're not going to touch. You know, again, is it worth $200 more to get a drive that can load the same game in 1 second? Probably not. You're probably better saving your $200, and that's a made up number because it's more expensive than that, but it's probably worth more to you to just wait the 3.5 seconds for your game to load than it is to spend $200 to possibly get a 1 second load time. I guess if you're that much of an enthusiast, again, this video series is probably not for you if you can afford those kind of things. So anyway, that takes care of the section on just basic overview of the 3-drive setup and some basic knowledge about storage mediums on PC as it relates to the OS and installs of games and everything else. So we will move on to what drives you should get and why next here. All right, so let's jump into what drives you should buy. This is going to have a little more information over each drive type and explaining what you should buy. And I'm going to be reading from a lot of notes, so if I'm looking off, that's why. Sorry, I don't have a good script set up here. But for your primary drive for your OS, you should be getting an NVMe, something that's going to plug into the socket on the board. If you look at the motherboard video I did, it should be in there showing you kind of what needs to plug in. I would recommend no more than 1 terabyte for your primary operating system. Keep the drive smaller if it's cheaper. If the cheapest is 1 terabyte, which that may be the case right now. Again, I'm recording this video it's June of 2026 at this point. So right now I could not find much better deals on reliable drives that were 512 gig over 1 terabyte. So you're probably just going to want to get a 1 terabyte drive. If you're getting an SSD, we had talked about that. You can get you a 512 gig SSD. Just know there will be a performance hit on OS load, but get at least a 512 gig, but no more than 1 terabyte for your primary Windows operating system, because you do not want to be loading a bunch of stuff on there. We only want the primary OS loaded on that NVMe, and anything that's required to be loaded there. That drive should be handling Windows updates, system updates that are required that have to be there. And to let you know, you don't need a very fast drive. I pulled some stats. Windows 11 on average, when you boot the machine up, if you're not leaving your machine all the time, I leave mine on all the time. Old days, general wisdom was to turn it off when not using it. These days, generally leave them on. So I can get updates and stuff. Just, it's important to do that. Otherwise, you're running your desktop like a laptop, and that leads to other problems, and that's a whole nother video. But Windows 11 loads between 2 and 4 gigs of data. So you do not need a top-tier NVMe to just load Windows and run Windows updates. Okay? You just need a drive that's going to be able to do that. An entry-level Western Digital Blue NVMe is going to handle that. This is where I say you're going to have a performance hit, because if you remember the speed chart we looked at for SSDs, you may notice a bit of an extension to the load time if it's trying to load 4 gigs at 500 megabytes a second. It's going to take some time. So get a budget entry NVMe. Don't get a super fast drive. The cost difference is about $100 between an entry level Western Digital Blue and like a gaming class or the faster class drives. And I'm going to say this probably a couple times in this video and throughout the series. Avoid anything branded as gaming. Looking at you, Western Digital Black. The reason that we're running everything OS related on this drive and want to keep it that way is that when Windows updates run, we don't want that to cause a performance issue while we're playing games. I know a lot of tech channels would look at this and be like, that shouldn't be an issue if you're running the right NVMe. It still can be. I have a fairly fast NVMe. I was lucky enough to get a Crucial drive before manufacturing issues and cut off, and Windows updates that run, and it would cause problems with games loaded on that drive. I've done testing with this. So it's not as bad as it used to be when you were running a mechanical hard drive as your OS and updates ran, or God, if you remember those days, or if you're running an SSD and notice that. In working environments, I talked about where we replaced mechanical hard drives with SSDs. That was one of the major uplift points, was we could run updates, we could push updates to systems or run background tasks, and there was less of an issue because the drives were a bit faster, but there still was a performance hit. So you want to make sure that your primary drive is only running Windows updates, only running system updates. What do I mean by system updates? Hardware, driver updates, stuff like that, and anything that has to be ran off of that primary drive. And then it should also be just temp storage. Avoid loading a lot of heavy data on your primary drive. We don't want a lot of writes to that drive, okay? We don't want to wear it out, and I'll explain why that is in a little bit. But we don't want to be doing anything but just, like I grabbed this image that I'm going to post on, social media someplace. So I grabbed this image and I copied it to my desktop to have. Use it as temp storage, then move your data someplace else. There are plenty of tutorials on how to map my documents, pictures, stuff like that to secondary drives. I encourage you to use that for multiple reasons. One is redundancy, so it's on a different drive, it's safe. But you can do, I don't recommend doing it to externals. You can. If it's something like my documents, you want to have it on probably a hard interface inside. But anyway, to avoid making this video much longer, we want to stick to just where we're at here. So as I lost my place here, but also make sure that this will kill a drive fast. I think I failed to put things in the right area here as I'm looking through, but you want to make sure that if you're doing any DVR recording, like you use Game Bar or anything, that you move that storage to a different drive. The mechanical will work for captures without an issue. Do not use your super fast NVMe for that, because it will cause issues. Yeah, I think I left out the part here, unfortunately, where I was going to talk about where NVMe's have a lifespan, because they do. There's a number of writes that you're limited to on an NVMe, and it's high. It's fairly high, but you can hit that, and some people will hit that cap, and then the drive will end up dying, and we want to avoid that. So I think that's going to be the end as I'm looking here. It's going to be towards the end. Sorry, I got a little out of order there. So again, the way I do my videos is a little more raw, if you will, but let's move on to drive 2 here. Drive 2 should be, I'm saying gaming NVMe. Do not buy a gaming listed NVMe unless the price is right. You want something in that higher end, the 7.4 gig read speed. Look more for that and make sure it's Gen 4. You want to be able to use whatever board you're getting should have a Gen 4 slot or 2 of those. You want to make sure you're using that to get you the maximum speed. This is going to be the drive where you're going to load games that have to run fast. What do I mean by that? If you install a game and it's running really bad and it's on the mechanical hard drive, you need to be able to move it over to an NVMe to run faster. Games that will have to run on an NVMe or they're just going to run bad, at this point I would say Dying Light 2, probably Stay Human. I have not even touched Stay Human yet. Cyberpunk will have to run there. Baldur's Gate 3, titles like that, and games that are just poorly optimized. So, where people are complaining about stuttering issues and stuff, it's less likely to be a processing memory use and more a storage use. I know that's controversial, but I'll go over reasons why and what that looks like in a bit. But this is just really simple and short, which is that just get a drive you're going to dedicate to your gaming NVMe. 1 terabyte or 2 terabyte, that's up to you in the games you're going to play. A lot of AAA titles are getting large, so 1 terabyte is going to go very fast, and this is why we want that side chart. Think of that 1 terabyte drive as 1,000 gigabytes. If you've installed a 750 gig game, you've used up most of that. Not that that's out there, but let's say GTA 6 comes out and it's 200 gigabytes. I forget what they said the size was going to be at this point, but you've used up a good portion of that drive. You have 800 gigabytes left, and that's going to go fast if the average AAA title is 70 to 80 gigs. Even at 70, 80 gigs, you're looking at about 10 games installed on that drive. Yes, I know there's more space left there. And again, towards the end of the video, we're going to talk about hard drive care and why you do not want to fill drives up. So, all right, so let's go to your third drive, which you should have, which is a mechanical hard drive. Why a mechanical hard drive? In that, this is going to be used for about 90% of the games you're going to play. Indie titles, older titles, the bulk of your library at this point is going to be that. Because while there's a lot of AAA titles out there, the majority of libraries people have are older games and indie games. And I find at this point, indie games tend to be better optimized or run better than some AAA titles out there. So also to go back to your second drive too, that high performance NVMe is probably going to be something you're going to want to use for competitive games. So Fortnite, Call of Duty, Battlefield, those tend to need very fast storage. So keep in mind that that's going to be something to use this for too. So talking about mech drives, I know people may laugh at this, but if you didn't know, the Xbox One and the PS4, those run on mechanical drives. They run on laptop size 5400 RPM hard drives, not SSDs, not now. The older Xbox One, the VCR looking one, as well as the, where'd it go here? The original PS4 and the PS4 Slim, while they ran on mechanical drives, they were slower because they used the SATA 2 interface. And it was a slower interface at the time. So to give you an idea, SATA 1 max speed was 150 megabytes a second. Okay, or SATA, however you prefer there. So when SATA 2 came out, it was 300 megs max. That was double the speed. That was huge. That enabled us to do a lot more with drives. And then SATA 3 caps out at 600 megabytes a second. So that got doubled again. And later revisions of the Xbox One and the PS4 got SATA 3 ports on there. So that's where those systems ran better. Like the PS4 Pro, that's why it ran better. Or the Xbox Series X, when that came out, that weird in-between Xbox, that's why it ran a bit better. It had that faster connector in there. Why didn't they use a faster SATA port? It was a cost issue at the time. When the Xbox came out, SATA 3 was expensive. SATA 2 was common. It was around. It was cheaper to do. It's also the same reason why these systems don't ship with SSDs. It was too expensive to install an SSD into the system. So we just got mechanical hard drives. So mechanical hard drives work. I would say at this point, if you were playing a game, and there's other PC nuance too, we'll get to that here in just a second, but if you were playing a game that ran on Xbox One or the PS4 and it ran okay there, running those games on the PC equivalent on a mechanical hard drive will probably run better than it did on the console. One, your PC is going to have more memory to work with, more RAM, and a better GPU, plus better processor. So that is going to provide a really good uplift to games that ran so-so or all right on consoles. They're just going to run better on a gaming PC for that reason alone, because you've got the faster SATA, and then you've also got all these other components that are much faster than what the console could do. So the other thing, just a side note here, is that the connection and hard drive, way back in the day, there was the parallel AT or PATA. We all called that IDE. If you see that long row of pins on that right-hand side image there, that we just called those IDE drives. We didn't call them PATA or parallel ATA. We called them PATA. Serial ATA or SATA, which is on the left there, is a better connection. It provides power and data connectors really easily, whereas with the PATA there, the IDE, there's 4 pins to the very right you can see, and I'll see if I can point to it. I'm bad at this here. Right up there. That was a power connector. So yes, they're 2 separate connectors on both drives, one for power, one for data, but it is more elegant on SATA drives, much more elegant than it used to be. And the number of times I saw bent pins on IDE drives because of sloppy text or just people not knowing what they're doing is infuriating, really bad. Yes, I have seen a few broken SATA connectors, but far less than I used to with IDE. So, but yeah, 90% of your library as you build it and as you play games is going to be running off of an older hard drive because it just works. And it's, you know, it's still a very usable medium. Even if you use an external USB 3.0 external hard drive for older games, still a good choice. Still better than just trying to get an NVMe. Also, capacities are much larger. We'll go over that. We're going to do more of a deep dive on mechanical hard drives here, going over a couple of different sections, kind of familiarizing with those and letting you know what you need to do. But that kind of sums up the 3 drives you should use and kind of why. We're going to get into more why here as I get into some more details about mechanical hard drives and drives in general. All right, so let's talk more about hard drives, mechanical drives here for a minute, and let's take a note what there is in terms of drives. There's 2 types of drives in size. There's a 3.5 inch and 2.5 inches, what they are. So the smaller drives are going to be the laptop size, right? And we want to avoid those for a desktop setup. I think the only case where you would want to use that would be in a micro build, but even then I would advise that you skip getting a mechanical drive in that size and putting it inside and just get an external, because the heat output is going to cause problems with your micro build if you're doing a micro build. This is if you're trying to like mock the build style of like an Xbox or a newer console, and you want that small form factor to be a set top thing. Like even for the for like this the Steam machine, you notice they're going to a different type of storage. I would still want a mechanical drive for the most of my library, but in a box that size, I would not want to use a laptop hard drive just because of how much heat that's going to put off. It would be an issue, especially if everything's tightly compacted. But you're going to want the 2.5 size drive, the bigger, chunkier guys is what you're going to want to put in there. If you're wondering for externals, just for reference, if you see a drive is listed as a portable USB, then that's most likely going to be a laptop sized hard drive, whereas just external hard drive is going to be non-portable. It's going to require a separate power source. That's going to be a full 2.5-inch hard drive in a bay. So, you know, you want to get the bigger size drive for your build. Also, laptop size drives are going to be limited to 2 to 5 terabytes. Most commonly, I only see those going as high as 4 terabytes. So, you know, you're not getting a lot out of there. You're going to have to switch to another drive later on at some point. But I wouldn't get those. Yeah, it's great they're self-powered. They use a little bit less electricity, but again, they get hot. And that's why I don't recommend those. That's why laptops also get very hot too. If you ever touched a laptop where the hard drive's at, if you know where it's at, you'll notice it gets warm. Both the processor, the GPU, and the hard drive all packed into a tight space together, putting off a lot of heat with barely enough ventilation, in my opinion, in most laptops to handle that. So, also the bigger drives are going to run quieter and they're going to be a lot smoother in terms of how they operate, and they're not going to put off as much heat. They have more area to disperse the heat. In most large size cases, as I'm looking at mine that you guys can't see, there's going to be enough room around that hard drive that airflow is going to remove a lot of that heat naturally. A lot of desktop size hard drives are using thick aluminum bases that draw that heat off, that kind of wick that heat away, if you will. So those cool a lot easier. I have never in all my years of using a desktop PC had a hard drive burnout because of heat. Those are generally always well handled. They do take quite a beating. Mechanical hard drives are like tanks. I have seen those things been beaten down and they still run, but they can run a little warm, but they do expel that heat pretty good. So lifespan of a hard drive. So I had touched on it earlier and didn't give quite many details, but NVMe's are rated in terabytes written is what they're at, and I'll touch on that in a little bit here. But mechanical hard drives are rated by hours, so 10,000 to 20,000 hours or 3 to 5 years is the general guidance given by the manufacturer before they expect the drives to fail. I have had drives last 10 years or more. I have used drives that are 10 years or more years older that have ran perfectly fine with no issues. They just last. Mechanical hard drives just last. And if you're looking for long-term data storage, or you're looking at playing older games, use them on the medium they were intended for. They still load pretty good. And even on a mechanical hard drive, by the way, games can run a bit better than they did on the console versions just because of how everything's connected in. There is that speed limit though, so keep in mind that certain games are not going to run well. But an indie game that's only got to load 200 megabytes of data, there's a lot of those out there, they're going to run fine on a mechanical drive. The majority of the 500 and something titles that I have on Steam run off of an 8 terabyte mechanical drive, 5400 RPM. So they run absolutely fine. There are a few that don't, but those are mainly newer games. So keep that in mind. Games like Deep Rock Galactic, if you played that, run fine on a mechanical drive. I run that off a mechanical drive. Load times aren't really that bad. Again, that game was designed at a time when it was running on the XboxOne, which is a 5400 RPM hard drive. So again, I can go into those examples all day, but the cost is going to be different. 4 terabytes on a mechanical hard drive is going to run you about the same, if not a little bit less. Right now, I can find 4 terabyte drives for about $150 for 4 terabytes. And NVMe 1 terabyte is running close to $200 right now. So, and same for SSDs. So there is a point where it's cheaper and you're getting a lot more storage. To To touch on 7,200 RPM drives, the other reason I don't, one, those run hotter and they have a less lifespan because they run that motor faster. That's why I don't like those. The failure rate is higher on 7,200 RPM drives, but the cost is also another 150. So for that same 4 terabytes, your cost jumps from 150 average to 300. To me, that's not worth it. It's just not worth the additional speed. I'm not getting into a breakdown of the speed differences. It's a little bit of an uplift on speed, but not enough, in my opinion, to matter. Not for what we're doing. So 4 terabytes is a good place for you to start. You will grow into that fairly quickly, and then eventually you'll be in an 8 terabyte drive. I am just barely getting to a point where I'm almost filling up an 8 terabyte drive, but that's from years and upon years of building a gaming library. And again, I like to have as many games installed as possible. You may not want that. So a 4 terabyte is probably going to be the nice happy medium spot where you can have a lot of games installed and play them, but you're not having everything installed. And at this point, I've stopped installing everything because as of this point, I have more than 8 terabytes worth of games in my library. That's between Steam, GOG, Epic, and other marketplaces. So plus physical media I don't even have installed that's on disk image at this point. So so that's a good place to start, both for cost too. 150 for a 4 terabyte drive is not bad, and that's going to get you a lot of titles to play. Plus a lot of indie games run great off mechanical drives. A lot of those do. Yes, they're optimized and run better on newer drives, sure, but again, are you really worried about a 3-second load time over a 1-second load time? That's a personal decision. For me, I don't mind waiting 3 seconds. To give you an example too of where this is more nostalgia, if you will, but I played Silent Hill 2 from disk, mind you, and it was running on USB 3 on the external DVD-ROM I had. There were no load screens. I felt like a part of the game was missing. So newer games don't have as involved load screens because they're just a bit faster. But some of those older games you may play, you may find you're missing that. A lot of people were unhappy because load screens at certain games like Fallout 4 and Skyrim are gone. They liked those load screens, but they're gone. If you're loading really fast, you don't need those load screens anymore. So, so to loop back on, what about external hard drives via HDDs via USB? I could go either way on this. You're losing about 100 megabytes a second because USB 3 is 100 megabytes a second slower than an internal SATA connector. That's up to you. There's going to be a speed difference, but again, is it noticeable and is it something you're going to have an issue with? If you're doing a micro build, absolutely go with USB 3 external hard drives. If you're going with, a desktop build, it's either way. One, you're going to have a number of SATA ports internal you're not using, so you can use those up. If you do an external drive, you're going to eat up one of the USB ports you have. If you don't have a lot of USB devices, you may not care and it may not matter. So there's some flexibility there. It really depends on what you think you want to do. But whatever you get, avoid anything branded gaming and keep it to 5,400 RPM drives. You should be able to go to a manufacturer's site like Seagate has external drives and see what the internal hard drive specs are. They should have it somewhere to let you know. Avoid 7,200 RPM. A lot of drives that fail have 7,200 RPM drives. So let's touch on used options because I've tried to work that into these videos. What about a used drive? What about a used hard drive, a used mechanical drive? You need to be very careful with that. You can search Marketplace for drives that you're going to find tons. They're everywhere. For here Marketplace, I live in Colorado Springs, so there's a lot of tech around me. I see a lot of under 1 terabyte drives that I'm not even going to touch, but there's a lot there. Prices are pretty cheap, and prices are going to be cheap on used drives. I'm going to go over on what to stay from, but make sure you test them. Make sure that they don't have bad sectors. We'll go over why in a bit. And make sure that it's at least on the if the external enclosure is USB 2.0 only, you probably don't want that. That being said, you do have some options. If you find external drives and you have a little bit of tech knowledge, or somebody that does, you might get a good deal. I got I think it was a 4 terabyte I got. It was an external hard drive. It was a Seagate, and the guy said that it was dead. So he sold it to me for like $50. Hey, $50 for a 4 terabyte drive, that's great. I had an idea that based on the model, and that's the other thing, look up the model that you're getting if you can get that to see what the common failures are. And based on that model, it looked like it was an enclosure issue, not the hard drive, but the enclosure. Sure enough, I got the drive, cracked the case, or shuck it. You can do that. Shucking it is when you crack open the case and pull the bare bones drive. That can be a great deal if you know what you're doing. So I got a 4 terabyte drive for $50. What was the problem? The power supply unit on the board, or on the enclosure, which is the part that interfaces the drive to power and data, that had gone bad. Drive was absolutely fine. It had a few hours on it, but it came back clean. The specs came back clean. Nothing showed any issues. I still use that drive. I figure it's at now. I think it's a throwaway I'm using for editing or something elsewhere. But you know, it's usable. It was a good deal. A lot of people don't know how to fix things. We talked about that with getting used computers. A lot of people don't realize maybe there's a configuration issue. They give up and they dump the machine and sell it to get something else. So there's that. But yeah, you can, you know, if you have somebody who's tech savvy, or if you were kind of tech savvy yourself, shucking drives can be a great source of getting hard drives from multiple projects. A lot of drives can be bought at discount. Again, I see drives listed as broken both on eBay and Facebook Marketplace that are being sold cheap, and the drive's probably absolutely fine. One tell is if they say it's clicking. If it's making clicking noises, don't buy that. Do not buy that. So we'll add that into this next section, which is what to stay away from. So avoid refurbished or remanufactured drives unless it is coming from the manufacturer. What do I mean by that? Don't even go to Amazon for refurbished, remanufactured, because I have seen too many times where I go to view a drive and it says it's from like Western Digital, and then I get to the checkout process and it's being sold by a third party, has no warranty. You want to get remanufactured or refurbished drives direct through the manufacturer. Western Digital has a program for that. You can save some money. Doesn't mean you will, but you can save some money there. Those come with warranty. Some come with 5 years. You want to try to get at least a 5-year warranty on that drive. And expect that it may fail after 5 years. But if you're in a pinch, you need something for now, that's a good place to start. Avoid old stock that looks repackaged. Again, going back to Amazon, for a while there were repackaged Western Digital enterprise drives. I forget the name that it was going under because it wasn't Western Digital, it was a different name, but they were enterprise drives. These were server class drives or high-end drives that had SATA connectors on them. They were failing. It was old stock that was failing, and those were being sold. And getting a return on those would be exceptionally difficult. So just keep in mind that they were cheap. They had problems and were a bad deal for that. And then avoid used drives unless you can run diagnostics and you're protected by a good return policy. Because the first thing you're going to do when you buy a used drive that's cheap is you're going to run it through like Crystal Disk Info, something like that. And you're going to want to check that drive's smart date out. Smart date is the diagnostic utility on a hard drive to see if it's got a lot of uptime, a lot of power on, power offs. Those don't matter as much, but they're important to look at. Like, it'll give you an idea where the drive is maybe used. And then bad sectors, as always, you know. Avoid cheap drives from unknown manufacturers. I've seen, there's a company, I forget who they are. They sell through Alibaba. Pardon me. They also sell through Newegg. I forget the name on them. They're really cheap. They're sold in external varieties and they're sold as internal drives. They're sold as gaming drives. These are drives that are remanufactured, recertified. That's the other term, recertified. Not by the manufacturer. They're recertified by a third party. They're either binned drives. If you guys had watched my video on CPUs talking about binned parts, binned parts are when it doesn't meet the manufacturer's specs, but it still works. They'll sell those binned parts off to third-party sellers, and those third-party sellers will sell them under their own warranty or terms, right? So unless you're doing the manufacturing yourself, I would highly advise avoiding binned parts or anything manufactured from that. Stick to well-known manufacturers, Western Digital, Seagate, Maxtor, Samsung, stuff like that. You know, it's just, you're going to run into problems. I don't care. Avoid this one. Next, at all costs, avoid this. If you see a drive being sold extremely cheap and it has any version of bad sectors, or again, clicking, grinding noises, it's not worth buying. Mechanical hard drives with clicking, grinding, or bad sectors, it's a failing drive. That is your warning to replace the drive, not buy it cheap. That should be common practice that you should understand is clicking, grinding, bad sectors is only going to get worse until the drive fails, until you have catastrophic failure. That is your warning sign to back up your data and move it. And again, if you're using a mechanical drive to just handle your mods and install, you know, games, if that drive dies, you're out some time for having to reinstall those. You're not out much else. Most games are cloud saved at this point. So, You know, it's really easy to just like, oh, that drive pooped out, I'll get me another one. That's the other reason we're doing 3 separate drives. Ease of use and replacing. If your gaming NVMe dies, your operating system's still functioning. You don't have to go through a full system format. You replace the drive, reinstall the games. You know, back up any data you may have had. Replace the drive, reinstall your games. If your mechanical hard drive fails, back up any data you need off that drive. Replace the drive, reinstall your games. Doesn't require an OS install. Drives can, most cases, can be hot swapped. I would still recommend shutting down and installing the drive, removing the old drive and installing the new one. But that's what you need to be aware of, and that's why it's important. Is that, you know, there are a lot of good deals to be had. There are a lot of rotten deals you can get yourself into. So that's probably what you need to know about mechanical hard drives at this point, kind of more in depth, know what you're looking for and how those are useful and how they're much more useful than what people lead on to. I will always be running a mechanical drive for a lot of older games and indie games, just because it makes more sense to, and it's a more cost-effective solution. In fact, just to bring this up, I just remembered this. For my Xbox One, I have a 10 terabyte external drive plugged in via USB that runs the majority of my Xbox library. There are a handful of games I can't that have to run an SSD, so that's an external SD running Dead by Daylight, Dying Light 2, it's running Fortnite, games like that, but the bulk of my Xbox library is running off of a 10 terabyte hard drive, external hard drive. It's a Western Digital. I think it's a MyBook is what it is. And it runs fine. It runs the updates fine. Could it be faster? Sure, but I'm not in a hurry and the updates run in the background. So what do I care? So anyway, yeah, so moving on. All right, let's talk about some basic care practices for hard drives. Now, I'm not talking about like having to dust them off or clean them or anything, but there's some basic stuff that you need to understand. Really, I think it's just like 1 or 2 things that you need to understand with storage, okay? Mechanical hard drives, NVMe's, SSDs kind of share one component, which is you need to keep at least 20% of that drive free. That number is all over the place. If you Google, some will say 5%, some will say 10, some will say 15. In my background in IT, 20% is where you want to keep things. And I think the built-in Windows red line warning is at 20%, but you want to keep 20% of your drive free. For mechanical hard drives, this is important because mechanical hard drives get file fragmentation. That's where it moves data from one section of the drive to the other. And then when you try to load that common data, because the hard drive tries to put that data in easy to access spots, but that gets cluttered. Fragmentation makes it so the drive has to constantly seek that data out. Defragmenting the drive, which as of Windows 10, defrags run automatically on mechanical hard drives. Trims, which is deleting empty space on NVMe's and SSDs, happens automatically. But in the old days, you used to have to randomly run a defrag, and that was an overnight process. It sucked. But now the OS is a little bit more intelligent about it, and it tries to keep that data organized. Also, for like the OS drive, you need that 20% for swap space, so Windows can move files about, run updates, do maintenance tasks, stuff like that. You need that free. Also, it is bad to fill an NVMe up. It will destroy an NVMe. It is bad for the life of the NVMe. Because it has hard time moving data around. So it has to work a bit harder, so it will cause issues for that. So I wanted to touch on here, you know, that's really the only care option, but I wanted to touch on AAA titles having an issue with the wrong storage. And I'm going to give you some examples. I said I would earlier, but we're going to talk about that here. I know some of this is all over the place. I'm sorry. But Dying Light 2 is my first experience firsthand with wrong storage for a AAA game. So Dying Light 2 came out, a friend bought me the game, I was looking forward to it, I really did enjoy it to play, but I started noticing an issue, and I had it installed on the internal drive, the mechanical hard drive and the Xbox One. Keep in mind, Dying Light 2 was a game sold as working on multiple platforms. PC, I think it was PC at the time, Xbox, the newer Xbox, Xbox One, PlayStation 4, and then PS5, right? So I was having issues. A lot of people were having issues. Same Cyberpunk had similar issues. I didn't experience those, but I recognized what they were. But let me explain what some of those issues were. So, fridges, when you'd open fridges, he would open the doors, and then he would open them again. The animation got doubled. Falling through the world when you would fast travel. You know, encountering enemy encounters and the enemies were just standing still. They didn't even notice I was there. Opening reward crates or chests and they were empty. Those were all related to slow storage. the game was not able to load fast enough beyond what it already had to keep up with events because the hard drive was too slow. The fix, I installed the game onto an SSD, an external USB 3.0 SSD plugged into the Xbox. Those issues immediately disappeared. So just that little bit of uplift helped. And so it's important to know that if you're using the wrong storage, Dying Light 2 on a mechanical hard drive is either not going to load or it's going to run horrid. Same with running on an SSD, probably going to run horribly. It may run better on desktop at this point. I don't know. I haven't tested that portion out for it. But in a lot of the testing I've done, if a game is acting really weird and I've got it installed on a mechanical hard drive, first thing I do is I move it over to an SSD to see if it helps. A lot of, believe it or not, and this, I know this may sound ridiculous, a lot of issues I encountered on Fallout 4 kind of resolved when I put them on at least an SSD, and playing Fallout 4 on an NVMe seemed to work a lot better. Just like with like New Vegas. New Vegas needed more RAM, so if you run the fix for that, that helps some issues, but then a lot of the weird things that happened in New Vegas for me got better when I loaded that onto an SSD. It was just able to access resources faster. But there's still glitches. Yes, at the end of the day, it's a Bethesda game, but a lot of problems seem to be resolved when they're put on better hardware. So let's get on to using SSDs, and then we're going to talk about NVMe's and how to be careful with those, and you know why we're also separating the drives out. Probably the more important portion of this video if you made it this far. So SSDs do have a purpose. I use an SSD for video editing still. I think that's a great place to use external SSDs. But you have to remember, and I guess this loops into SSDs and NVMe's have a limited write count. That means that once you hit that maximum, the drive will die. It will just not work anymore. And it is high. I forget where I put the count here at, but you get like 1,000 terabyte writes is what you get. And I know that sounds like a lot. Looking at the sizing chart we had at the beginning, 1,000 terabyte writes, that's a lot of data. It is and it isn't. A lot of people do not realize how much data they go through. They don't realize how much they're using until they start, really seeing problems or tracking it. So the reason we want a separate NVMe for our OS besides Windows updates, which are going to count as writes to the drive, hardware updates, writes to the drive, is that everything you do on the internet will be cached to a browser. That cache is written to a hard drive. And I took some quick notes, but if you're watching YouTube in high definition, just 1080, the average hour of watching will be 2.5 gigs, not 2.5 gigs, sorry, I got the wrong number there, will be 2.5 gigs to 41 gigs per hour. That is HD, sorry. That's a lot. That's a lot of writes to the cache. If you're a 4K person, which I still find laughable, and you're watching YouTube in 4K for whatever dumb reason, 15 gigs to 23 gigs per hour of video watched. Do you watch streaming content like Netflix or other platforms on your machine? That data's got to cache someplace. Are you, video editing? That's going to be writes as well. Video editing will be by far the fastest. I had a friend who killed his primary hard drive because he was doing video editing on it and didn't realize it was adding up that quickly. Twitch streaming, that data's got to process someplace. It's going to cache locally to your machine before it's out. So that's quickly going to eat up writes on your drive. All of that will. If we use a secondary hard drive, like you can use storage on a mechanical hard drive for streaming, stuff like that. Cache, I don't think it's advisable to move the cache around, but you can lessen the impact of the damage to your primary NVMe if you're not doing video editing there. But video editing, in my opinion, at this point, should be done on an external SSD. You can do it to a mechanical hard drive, internal or external. It's just going to be slower. So if you're looking for faster, like I do these videos that 20 to 30 minutes, it takes me like 5 minutes to render the full video after I've edited. So it's not too bad. But keep everything off the primary and run an SSD as an external. You can generally get used SSDs cheap on marketplaces if you're doing video editing. And as long as you have a backup for your finalized project, you're basically just using these as scratch disks is what you're using. So I would keep it to that. But don't be, using your gaming NVMe for video editing. I don't care how fast it is. You're going to kill that drive, and that's the more expensive component there. Your mechanical hard drive, put your mods there. That way, gaming mods, don't have to be on a super fast drive. Gaming mods are usually very small. We're talking megabytes. Yes, there are some overhauls, but if it's a game like Fallout 3 or New Vegas and you're doing an overhaul for, those are going to be loaded with the world anyway, and you're doing that to a game that was meant to run on a system that ran a mechanical hard drive anyway, so it shouldn't be a problem. So I think that's about all that I've got to cover over drives. Hopefully this video isn't too long. Again, I don't know the runtime until I'm done doing these, but that's kind of why you should look at a 3 hard drive setup to kind of close this out, is that you want a primary drive that's not going to be touched by much for your operating system. So the system doesn't have a failure because you're just abusing that drive. You want a secondary gaming NVMe that's fast for AAA titles, so you can enjoy those, you know, in a good experience. And then a mechanical hard drive to handle mods, you know, older games, indie games, stuff like that. You will find, as I have, failure rates decrease dramatically when you spread the wealth among drives, if you will. It just makes for a better experience. I know that adds to the cost. You can ignore all this and do everything off of a 1 terabyte SSD on your primary system, or just 2 SSDs, but I would recommend that you do a 3 drive split, and these are the reasons for that. So hope this helped you guys. If you have any questions, comments, whatnot, leave it in the comment section below. This video is disorganized. I do apologize. There was just a lot to cover within here, but I was glad to finally be able to get to this, because I do think there's a lot of information that's left out about mechanical hard drives and storage in general that gets people buying the wrong stuff. So please stop buying the wrong components for your builds and be more realistic about what you're doing. And again, hope this helps, guys. If I missed anything, as usual, let me know in the comments below. But yeah, hope that helps. And until next time, we're going to be moving on to the outlier topics here. Next one up is going to be cooling. That should be a quick video, but we're just going to go over air cooling and why I don't really use AIOs, and explain that, because I think there's some real world situations people aren't looking at. But anyways, that video should be out hopefully next week, but this is the storage video for now, guys. Hope that helped. And again, bye.